Okay, here is the speed run of the Excel Esports case Origami, the finals from 2025 Excel World Championship. I'm going to be using some OA robot. It's pre-built Lambdas. See the descriptions if you want to know about that. All right, so only numbers of the text before the C, and then the text after the C is the column. The input paper is here. I'm just doing this because I know I need to make a lambda, right? So the index of this by here and here is that, but then I'm going to make this my, so Control O to bring up the OA robot menu, right? This is going to be an input, and this is going to be an input. And then I'm going to save lambda as RC index. All right. Level 1, and it's lambdafied. This, I get the center cell. I don't want the center cell. I want the top left cell because that's how the rest of the case is going to work. So ref to RC of this minus the size minus 1/2, right? So like going up 3 spaces of each in this case. Then that is a ref, because this is going to be the RC to ref. I always do that backwards. This is going to be the input for my thing. Now I'm going to just undo that, right, and give me back my coordinates. Ref to RC of this, but like this now is going to be an input cell. The size is the other input cell, right? Given the size and the top left, what's the paper? Right, so I need the rows, I need the columns, and I need the paper. And that I could get by saving this as all paper. Right, so the rows are going to be based on the first one of these, right? So 1 and 1. And this one's going to be based on, well, I'll do that in a second, right? But what I want is a sequence of length of the size, right? With 1 starting at that. But I got to adjust it for the space. So I got to remove 3 rows of blank space and 1 column of blank space on the sheet. To offset that, and it's the second one of those to give me the column numbers, right? And then the paper is simply choose calls, choose rows of all paper by all the rows, close, and all the columns, boom. The sum of this is the answer to this question, the sum not just of that, but of the whole thing, right? The paper is, but that's the lambda that I want to make, is of the paper itself. So save lambda as, and we're going to call this the paper lambda. So there's the paper lambda, and there's level 2. Now it's time to fold. So we'll do our lambda prep first. Not exactly how you do it in a real case, but it's good for a speed run. All right, so that's the input. I need to know the size, and I need to know half of the size, because I'm going to use that a lot, so I might as well make a variable for it. So there's the size, and there is half the size. I got to remember to use the variables and not the hard-coded, because those are going to change. I need rows, right? So for the diagonals, so the row number is going to be based on make array, that many rows, that many columns, and the formula for just the row number is lambda RCR. And then the formula for the column number is lambda RCC. I need to also add them and subtract them for the diagonals. So here's row plus column, right? And if you look at this when I make it, like you can see the diagonals are here, right? 9, 10, 11, like gives you the diagonals. The other one is row minus column. So now the same thing, but row minus column gives you the diagonals going the other way. Now I'm going to do some transformations, right? I have a transform array lambda that does rotations and splits, flips and rotations. So it takes that and it flips it by the arrow, the up-down arrow, right? Which is that. Then the same thing is going to apply to the other orthogonals. Except that's not an orthogonal. The other orthogonals, except that these are going to be based on the left-right arrow instead of the up-down arrow. And if you compare, each of the examples to what I'm doing, you can see that, it matches so far. All right, so for these, what it is it's the index of the original, right? No, not that. I keep thinking that will give me the array, but it won't. All right, the index of the original, where the column is the row and the row is the column. All right, so that is correct for this one and its opposite, which is here. For these, it's the same thing, but it's 9 minus that, or 8 plus 1 minus that, because you got to like flip them, right? Like it's not, it's in the reverse direction, right? So 8, 15, 57, yeah, that's right. And then the same thing applies to this one. All right, so now I need some masks. So X sequence is my lambda for that. This one's going to be starting at 1, going to 0 by -1, repeating each element 4 times. But not 4 times, not hard code. That's what I just reminded myself. No hard code. It's got to be based on that. All right, so now this is going to be the opposite for the down one, right? So this is just going to go from 0 to 1 by +1. And I'll line these up just for fun here. And then the sideways ones are this, but just, on their side. This one has also got to be the other one, right? Yeah, this one and also transposed, right? So to row to transpose it. That looks right. And then the same thing over here, but going down instead of going up, right, by -1. This looks good so far. And for these, it's going to be based on these, right? So if this thing is greater than or equal to 0, then 1, otherwise 0. Is that the right mask? No, that's the opposite. So do that. Yep, that's the right mask for that one. Then the opposite of that one is here, which is simply just flip this around. And then the other ones are the same, but based on the row plus column instead of the row minus column. And the threshold is not 0, but the threshold is 9, but it's not really 9. It is this plus 1. All right, that looks exactly right to me based on the example. This one is flippy flip like that. All right, so now then our outputs are simply, so if the transpose version is equal to 0, it does not override the existing one, and we get the existing one. If it does, then yes, it does. If it is, not 0, then it overwrites it, all subject to being multiplied by the mask at the end. All right. And in order to copy this over, I'm just going to keep this C locked. Everything else is going to fly with me. And I compare this now to this, and I see that they're the same. So I know my lambda's working, right? 1964 looks good. 4160. If 3 corners are right, that means I did it, right? 5781. 2532 8, good. 1864, good. 864 61. As long as I didn't hard code anything, I shouldn't have. 57 64 8, good. All right, and make so I can see the arrows, right? And then this is FU for fold up. Kind of a funny one, but just fold up. That's it. Don't get excited. FUR, fold up right. FR, fold right. DR, fold down right. Yeah. Not a president, just fold down right. FD for fold down. F down left. This one is just left, right? So FL. And this one is up left. FUL. So now let's see if we can do a multiple folding, right? So here is the N. Right, and let's say by direction is this direction. Right, and we're going to call these our inputs, right? I for input cells. And I'm going to need a little lookup table to help me pick the lambda based on the arrow, right? So here, and then this will just be sequence 8. And now, so the out here is going to be based on looking up the arrow on the arrow list, returning on the number list, and then based on that, we're going to choose one of these lambdas. And what are the lambdas? Well, the first one I remember is FU. So that's the first one, and then I'm going to copy that 7 times. 1, 2, 3, 4, 5, 6, 7. No comma and a parentheses there, and then I just got to fill these in. So D, L, R, U, L, U, R, D, L, and D, R. Boom. All right, so now that should be a folding lambda. Call that fold. So now equals fold of this by this direction, and then fold of this is just testing, but this by this direction. Looks good. Looks like I'm in good shape. All right, we're ready to fold. So now we're going to do a paper that is, well, let's do the whole thing. We're going to do the RC index based on this RC index. It's going to be a fold, and it's going to be a paper based on the size 8 in the instructions, right? And the top left is there. The folding direction is right in this one, so arrow R is how I handle that. That should be it, right? Yep. So there's level 3. This one is going to be RC index of fold of paper, that size, that top left by this direction, and I forgot to put the index goes first because it was on the left in level 1, so it's the very first thing. All right, that looks promising. Now I'll just, use my string to array lambda just to bring these out. So now it's going to be RC index of this, of fold paper, size 6 starting there. First fold direction is here, second fold direction is here. And close RC index, right? Yes, that's a good, correct answer. This one I'm going to skip for a second, do level 7. So string to array of this, right? Here I don't need RC index, just sum, right? So sum fold of a paper, right? The paper that has size 6 and starts there. There's the first fold, close, second fold, closed, comma, third fold, close the sum. And yeah, I don't know why it wants to do this. It did this to me before. I don't know why I feel like if I separate these, it'll work. I don't know why I have to separate them, but I do. It's probably some array reference thing that I'm not understanding. All right, but I separate those and then do that sum, and I'll bet that's good. We'll check everything in a second. But first, I've got to deal with this, which requires this quadrant thing, which is I don't have a lambda for yet. So first of all, let's do a paper of size 6 with the top left cell there. And then let's fold it by this direction. All right, now I got to do some stuff here. I need to pick certain rows and I need to pick certain columns based on the arrow. All right, so there is, no, I don't need accessibility right this second, but thank you. Need those, right? So if it's on the left quadrant, then it starts at, so it's on the top quadrant, then it starts at 1. If it's on the left side, then it starts at 1 column, right? And otherwise it is half of this, it starts at 4, right? So half of this plus 1, right, is there. That's the column it'll start on in each case. And then in the actual correct case, right, which is this one, X looking up here on this one, now I know what I want, right? So it's going to be equals choose calls. I gotta leave enough room for this. I mean, this I'm just gonna sum, right? So choose calls, choose rows of this, right? And then the rows that I want are a sequence that is this over 2 long, 1 wide, and starts at the row. Right, and that is the end of choose rows. In addition, now I need the columns, right, which is the same thing, but it starts at the column number, which is here. Then I close out the choose columns and close out the sum, and God willing, we should be at 1,000 points 18 minutes in. Let's see. Quick scroll on all of them just for dramatic sake. I'm not seeing any X's. 1,000 points. All right. Sum of all of these. So it's the sum of all paper times a mask, right? Which is make array 256, right? So this whole thing is 256 by 256. And the lambda for just that diagonal is RC, R equals C. Close, did he close? Like that. All right, the ones in the middle is choose calls, choose rows of all paper, and it is what, 128 and 129, right? Because it's half of 256, right? And the same things, 128 and 129. So as long as I'm grabbing 128, 129, I've got to sum them up. Balance my parentheses here. All right, the largest sum in a 5x1. I'm going to do this as little as sheets just for fun. I'm I'm sure there's a nice formula I could use for it, but I don't feel like it. I've used so many formulas in this solve so far. So equals just the sum of these 5 going down. Copy, Control Shift arrows, Control V. This is still pretty fast, right? So sum, I mean, it's not the fastest, but it's fast enough for me. There's 5 of those. It's the fastest because I don't have to think about it. All right, and then Control V, but not Control Shift V, because that would paste values, which I don't want. All right, so equals the max of this and this. Boom. All right, so that one I'll do last because it's the hardest. This I'm also going to do with a little sheet here, right? So let's say that I wanted to, and I'll give myself room so I don't spill. So let's say I wanted to, first of all, I mean, I'm just going to pull these, right? So let's say I just, the center now has, no, that's not the center, equals these, right? So let us do this. I got to call it. That is going to spill, but that's fine, whatever. So I got to call it because I got to filter it, right? So filter to call of that, where to call of that is less than or equal to 9, right? So those are the ones that are less than or equal to 9. Now I'm going to unique it and sum it. No, not like that. I'm going to unique it first and then sum it. Boom, boom. And that's it, right? So if this comes out to 45, then I know I've got my thing, right? Because I know that the sum of the numbers from 1 to 9 is 40. 45? Yeah, 45. That sounds right. Let's see if it's right. 45. Looking in the values, there it is. K34 is the address. K34, boom. Nope, that's the wrong question though. K34, boom. All right, this one that I skipped. All right, my folding lambdas will not work for this because once you fold it once, it's not a square anymore, and my folding lambdas only work on squares. So sequence, we're gonna start with sequence of 256 columns, right? This just goes on and on and on. And I'm going to figure out how many columns it is, right? Which should be 256 to start with. So now I'm going to fold it. So to fold it, I'm going to flip it first of all, right? So I'm going to use my transform array and flip based on the left-right arrow, right? So that will flip it. And I also need to drop some of it, right? So I'm going to drop this over 2, right? But that's rows. Drop this over 2 columns like that. And there we go, that's folding it. All right, so if I keep folding it forever, when is it 4 columns? Well, they're these 4 columns. It's columns 85 to 88. All right, so equals sum, choose calls all paper of 85, these 4 here, right? Boing, boing. That's it. I'll show the answer in addition to the points. 105.84. Thank you for watching. 23 minutes, 35 seconds. Thanks. Bye.